Hi everyone, this is André. In this series of videos, I'll try to show you how to use the XFNF5 program to perform a plane analysis, starting from foil design right to the stability of analysis of the complete plane. I'll assume that you're familiar with the basic concepts of aerodynamics, such as lift, drag, Reynolds numbers, and also things like viscosity, laminar flow, turbulence, transition from one flow to the other, all these things which are at the core of the X-Foil program. Okay, so let's start. First thing we need to do is launch the XFNF5 program, and that's it. And we switch directly to the direct foil analysis. Switch to the foil view, and let's design a NACA foil to start with. I like to use the NACA 9 for my elevator and fin, so I just type in NACA 9 and OK. Let's see what the panels look like. Now, whether you design a foil or you load it from a file, the first thing you should do is always repanel the foil to make it more easily analyzable by the X-Foil engine. So usually I redesign with between 100 and 150 panels. Even if it says here 99, you should still repanel just to make sure that the distribution of panels is smooth and just overwrite it. This is important. The panels at the leading edge, their distribution can make a big difference in the convergence of the X-Foil analysis. Okay, let's load another airfoil from file this time. Let's see, I'll load one of Mark Dreller's foils, such as the AG45, why not? And same thing, first thing I do is I always repanel this foil. There are a little less nodes here, 100 should be okay, and OK. And overwrite the foil that has just been loaded. So now we have two foils in our database, and it's time to go on with the analysis. Now, you should always save regularly your project, because although I do my best to make sure that this is a stable program, there are still some issues, so it's a good practice to do some regular savings. Now that we have two foils loaded, maybe we can run an analysis. So the first thing to do is to define such an analysis, and we'll use a type 1 analysis at 100,000 Reynolds number, and we'll leave the other parameters unchanged. The type of polars are explained in the X-Foil documentation. I won't go over them here. Let's say that for foils I only use type 1, but type 2 and type 4 will be more useful for full plane analysis. So we type OK, and our analysis appears in this top list box. So we can see it's a type 1 analysis, 100,000 Reynolds number, 0 Mach number, and the transition criterion from turbulent to laminar to turbulent is equal to 9. And all we have to do is click Analyze, and if our our foil and our analysis are well defined, we'll get straight away a result here in the pressure coefficient plot versus lengthwise direction. We can't really see the color here, so let's lighten it a bit. Oops. There we are. And let's thicken the plot. There we are here. So we can also visualize the pressure distribution on the foil surfaces. We can have a look at the boundary layer shape here. But to really understand how this foil behaves, the best thing to do is run a sequential analysis, starting from instance from 0 degrees to 10 degrees by increment of 0.5 degrees. Let's go. And in the negative AOA range, I'll go from 0 to 6 degrees. Now it's useful, not important, but useful to always start your analysis starting from 0, because this makes the X-foil convergence much easier. So now we have a full range of what I call operating points here, ranging from minus 5.5 to 10. This means that the minus 6 degree analysis did not converge and couldn't generate an operating point. So, for instance, we can look at all the curves, show all operating points here. Now it's a bit difficult to read, so let's look only at the current operating point and reset the scales. Okay. At the same time, there has been a polar curve which has been generated, which we can see by switching to the polar view here. And here again, we can change its color and its style if we wish to. Okay, here it is. So we have one polar object here, or for the AG25 foil. And I'll save again just to make sure.